Welcome, welcome. My name is Lloyd Borrell. I'm your host. Today, I'm thrilled to have as my guest, Alex Stadtner. Alex Stadtner has a degree in environmental science and environmental policy. He has a master's degree in resource management and administration, and he is a certified building biologist and president and senior consultant at Healthy Building Science. Alex Stadtner, welcome to the EMF Health Summit.
Thank you. I'm excited to be here.
I'm really excited to have you too. We've already spoken before in the past. You've been on my podcast, and you shared some great information. So I'm thrilled to have you here today again. So I know you started out as a green building consultant. So I'd like to start simply by asking you, what was it that sparked your interest in EMF, so to speak?
Well, I was in a green building field working mostly with design architects and engineers on large commercial buildings, doing LEED consulting, L-E-E-D. Mm-hmm. And I was always most fascinated with the indoor environmental quality aspects. And so I continued to learn about indoor environmental quality and how to kind of push a healthy building beyond LEED. And one day I came across the building biology group, or the Institute for Building Biology and Ecology. The director at the time was at a conference in San Francisco, and I went and I listened to her, and she was talking about electromagnetic fields. And I thought, I hadn't heard too much about that in the States. And so, and there was no credits for that in LEED, which was my basis for information about what's a healthy building. I thought, maybe this is something worth exploring. So I eventually went to the 5-day seminar with the building biologists on electromagnetic radiation, and wow, it just blew my mind. It was a life-changing event. And George Carlo was there, Spark, a handful of kind of old school EMF consultants there, Larry Gust included, talking about electromagnetic fields and radiation, something I hadn't learned anything about in my course of studies for environmental science or healthy buildings. And that forever changed the course of my life. So it was largely the building biology group though, in that 5-day seminar.
Yeah. And it is amazing. And I've heard this time and time again where, it's either that people have had this fascination with EMFs, and played about with radio, ham radio and things like that ever since they were a kid, or it's just came into their world like that, and that was it. They just, got really into it, and it took off like that. So, I'd like to, today, I'd like to focus on creating a low EMF home, if we can. Okay. So there's various scenarios here I'd like to talk about. Scenario one, buying / renting an existing property, what kind of things that we need to look at. Scenario two, building or creating your low EMF home from scratch. So you've got a plot of land, and then you're going to build something, and you're going to try and make it low EMF. And then scenario number three, resolving issues in an existing EMF home, which I guess is going to be where most people are at, okay? So if we can start with the first one, choosing a low EMF home to rent or buy, in terms of external factors, I guess that's the first thing. And what comes to mind is like cell towers and power lines. So so what can you say to that question? What should we be looking at?
Well, there are a couple things that are really challenging to cope with. I would say the external large high voltage power lines is something that's just impractical to mitigate from a residential standpoint. So should a building be within 100 yards or 100 meters of a high voltage power line, particularly the type on a metal pole, large signage, high voltage, usually has a lot of clearance underneath it. Those those larger distribution lines can be very problematic, and you can find 6, 10, sometimes 15 milligauss near the base. where building biologists are trying to get below 0.2 milligauss. And so there can be an entire neighborhood that's in close proximity to those larger power lines that are above that limit. So when you can tell that from a Google image, even before you get to the place. You can see if it's close to large power lines. The second piece that you alluded to would be a cellular antenna or a cell tower. Those, I believe, can be more easily mitigated, but you'll never get it. It is challenging when it's very close. If you have direct line of sight to a large cell antenna and it's less than a quarter mile, it's going to be relatively high radio frequency radiation, especially outdoors and sometimes indoors, depending on the materials of the building. So if, for instance, there's a foil-lined insulation, or it has aluminum siding, or any other sort of metal component in its assembly, even stucco and concrete block will help minimize some of the radio frequency radiation. But when you're just looking from a sheer sight standpoint, those are the two things that would be big red flags: large power lines or a cellular antenna nearby. And statistically, it's more likely that people have introduced things into their unit, or their neighbor in a building has Wi-Fi and it happens to be right next to their headboard, or there's wiring error in the building that results in elevated magnetic fields. All those things can happen regardless of proximity to those external sources.
Right, agreed. And the most popular question is, with regard to those two subjects, the power lines and the cell towers, is what distance is safe? And of course the answer is you don't know until you get your meter out and you take a reading. But if you could hazard a guess, notably because the cell tower, it's depends on lots of factors, doesn't it? The direction, so on. But in terms of the power lines, could you give like a general indication in terms of how many feet away, looking at, is there like a general assessment we can make here as to what's safe?
I'm trying to pull up a blog. Within the building biology group, they have a number of thresholds. Let me try to share my screen real quick. And let's see, can you see that?
I can.
Well, this is a blog that we wrote, just republishing largely some facts out of the building biology guidelines. And so on this, I'm just going to highlight a few. These are some, so if you do a Google search for EMF rules of thumb or best practices, this should pop up. And building more than a half mile from an electric power transmission line, that's bullet point number 1. So they say a half mile. That is highly dependent. As you said, you might not know until you pull out your meters. They recommend more than 100 feet from a utility substation. They recommend more than 25 feet from a electrical transformer. So this would be the kind of small trash can type that you might see mounted on a telephone pole, or a large green box in a front yard. They recommend 75 feet from overhead, or 25 feet from buried electrical distribution lines. That can be very challenging depending on the neighborhood. In a high density neighborhood, that can be very challenging. And again, these are just rules of thumb. And they also recommend a neighborhood without wireless broadband internet service, but that with 5G in the United States is quickly becoming everywhere. So it can be very challenging to find a place. And lastly, they just say not in direct line of sight of a cell antenna. So hopefully, maybe those are some good rules.
Yeah, that's some really good tips there. And I guess most of that is pretty much common sense, or it seems to me to be common sense, but then I'm talking about this all day long. But there is a more sophisticated way of doing this, is there not? And that is with GPS to do EMF mapping. Can you just talk to that for a second?
Oh yeah, you can do some very interesting things with a GPS and some data logging equipment. It's not easy, and it's not for people who don't have enough money to invest in significant equipment. let me just, I think I have another blog, GPS, do EMF and GPS mapping. You can get some really interesting maps, so to speak. And so I'll just pull this up on the screen, but you essentially link a GPS and the timing of that GPS locations to the timing of data logging, either radio frequency radiation or magnetic fields, electric fields. You can do it for any. But in this case, we did magnetic fields. And it's a little wonky because you're in a vehicle. So, and that can throw things off when you're in transit. But let me see if I can share this. So this was something actually that when Cameron Doss worked with me, and his name's now Cameron Ferris, but he was really good with the tech, and he was able to do this exercise. So you can literally drive and put your GPS on and be monitoring where you go. And then as you go underneath the power line, it might be kind of hard to see this in resolution, but as you go underneath a power line, you see a spike. And so you can drive around a neighborhood. This scale is perhaps a little tricky, but you can drive around a neighborhood and see where it's elevated. And you can do the same with radio frequency radiation. Like this is crossing the Golden Gate Bridge.
Wow.
This image here. So going from San Francisco over the Golden Gate Bridge, you see periodic spikes. That's probably where it was going underneath power lines. And on a smaller scale, doesn't look like we have as much, but on a smaller scale, it's even more interesting because you can go around your neighborhood.
Yeah, yeah.
But it's tricky, and it gets thrown off. And when you're doing it for radio frequency radiation, it is it can be just thrown off by the car next to you with their Bluetooth or somebody with a cellular phone. But when you do drive down and you see line of sight to an antenna, it will inevitably spike. And if you have audio on a radio frequency meter, you get that too, pretty obviously.
So that data you've just shared with me, that is connecting GPS to an EMF meter with data logging ability. Is that correct?
Yeah, technically, I don't think they actually connect, but you overlay the data.
Okay.
And there's a way to do this. I think the most common, the only way I've seen it done is using the NFA, the Gigahertz Solutions NFA 1000 meter. I should have, Mary, you want to see one? And so this little sucker has the ability to do some data logging, and then you overlay it with the time that the GPS route took. And so in that way, you're able to do either radio frequency radiation, using the gigahertz, you now have to have two.
Yes.
Or the lower frequency, lower bandwidth, using this NFA 1000, you can do it for electric or magnetic field. Electric would not be so good, in a vehicle.
Yes.
I suppose you could even use the walking GPS with better granularity. And we've done that. We've experimented with that in some neighborhoods to illustrate.
Yeah.
See what it's, walking a transect and then showing a zoomed in Google image with the magnetic fields as it peaks underneath the wire and then drops off as you walk past it. It's pretty cool.
Yeah, yeah. Okay, so that's scenario one. If I can ask you about scenario two. So scenario two is we are building a low EMF home, creating this low EMF home from scratch. So what can you give us some tips here on, choice of building materials, for instance? What building materials should we be using here?
Okay. Well, there's an entire, I might break it up a little differently, but there's a lot to be said about air quality in buildings. And so we'll focus this discussion on the electromagnetic radiation components. But location and layout is really important. So one of the first things when we're consulting on a design project is we'd like to see a floor plan, we'd like to see an electrical plan, a lighting plan, and a mechanical plan. Where are you going to put the heater? Where are you going to put the furnace? Where are you going to put outlets? Where are you going to put the sub panels and the main panel? Where's the electric drop down? all of those elements, just in terms of layout, are really important. If you're having a second story and it happens to be over a lot of can lights in the kitchen, and all the transformers are going to be in the ceiling above the kitchen, but which happens to be in the floor below a bed, those types of layout decisions are really important. And then when it comes to materials, we like to start with a site evaluation for all those things we discussed earlier. Are there external sources that we need to consider when we're designing the envelope or the roof of this building? And if there are, so say it's magnetic fields, maybe we can do some magnetic field shielding if it's low enough to make some impact on an exterior wall. More often, exterior wall shielding would be for radio frequency radiation. So then once we know, okay, well, are there any things outside? We look at the layout. We don't put headboards or sleeping or high use areas, using the building biology terminology, next to known point sources like a refrigerator or an electric oven, things like that. Then we can talk about other material choices. So to avoid electric fields, there's primarily two ways of doing it: use metal clad wiring or conduit to shield the electric fields, or install demand switches, typically these days, remote demand switches that would control the circuits around the sleeping area. And that, again, if you're starting from scratch, you can really design well and say, okay, we're just going to have one circuit or two, a lighting load and a outlet load around this bedroom, no other wires from other circuits. All we have to do is to control those two circuits, turn them off. Or all we have to do is use metal clad around that particular protected area. And then for the radio frequency radiation, there's a lot of options in terms of materials. And that depends on the wall assembly. As I said, some insulations, like a foil-backed foam, for example, will do an effective job at mitigating radio frequency transmission through a wall assembly. So that may already be included in somebody's base package, so there's no additional cost. On the other hand, they might not have any shielding or need it, in which case we would point towards, oftentimes we use a really fine metal mesh, like a stainless steel fine mesh. You can't even see through it. It's very fine. Probably have a sample here.
Right.
But that's quite effective.
Okay. So the degree to which you're going to be doing this EMF mitigation, trying to get these exposure levels down for these various frequencies, these various categories of electromagnetic fields, that you've been talking about here, be it radio frequency radiation, electric fields, magnetic fields, the degree, and even dirty electricity, which we've not talked about, which I know you deal with as well. But the degree that you're going to be mitigating all that and dealing with all that, during this construction, and as you say, you're going right from the plans, before the thing's built. Obviously, you want to be right there at the beginning. But the degree to which you're doing all that is going to depend on the particular sensitivities, on the particular requirements of the client, I guess. It won't be the same for everybody. Is that fair to say?
Yeah, so on every job, there's people, there's pollutants, there's pathways, and we kind of have to think about all of those things. And the building itself kind of covers all three. But if somebody's not particularly sensitive, many people aren't, then they're able to survive until they have some critical event or they're otherwise overburdened and then become sensitive. So we have some people that want a full-on sanctuary, either just in their sleeping area or for their entire building. The majority of our clients, however, say, oh, we've got teenagers. There's no way they're never going to use Wi-Fi. We have friends over. They're going to think it's weird when they can't get a cell signal in our apartment. So we need to have some connection to the outdoors. And so more often than not, when you start explaining the ramifications of going all the way, which include cost and loss of convenience, frankly, most people say, oh, that sounds good, but I'm not that sensitive. And so you have to listen to the people, and you have to explain both in terms of cost and just complexity of the building. And but really what seems to move most people is the convenience factor, and just kind of a reality of, well, I do like to use my cell phone sometimes in the house, and therefore we wouldn't put shielding on all 4 walls and the ceiling, because that would really eliminate the radio frequency radiation to the point where you can't get a cellular signal indoors.
Yes.
Interestingly, a lot of the windows that they used to sell in the United States had good RF blast shielding capabilities. And when people were getting window upgrades, especially in concrete buildings and stucco buildings, after the new windows came in, wait a minute, we don't have a cell signal anymore. And those window companies got enough complaints to where they've now re-engineered the gases and the films in their windows to not block radio frequency radiation. And now if you want that, you have to pay extra and have it added.
Yeah. It's topsy-turvy world. But yeah, so what you're saying here is people perhaps start out with good intentions, and then you start explaining what that will mean to have this full-on shielding. And then unless people are really what we call electrically hypersensitive, then there's few people that are really willing to go the whole 9 yards, because it does impinge on how you live.
That's right.
Your home, so it's somewhere where you're spending a lot of time. Most people.
Right.
But I want to ask you, just go back to one point you raised here, which, just to give some clarity, is on this question of demand switches. Because if you could just talk to that, explain. So demand switches, we're talking about dealing with electric fields. Super important, because the bedroom is where you sleep, and we need to create this sanctuary, this safe place, which really, if we're going to go overboard anywhere on this whole EMF question, it's in the bedroom, yeah? And so this EMF, this demand switch, is a device which enables you to reduce significantly the electric fields. Can you just speak to that a little bit?
Sure. So frequently, most people, when they're testing electric fields, they use body voltage testing. And that body voltage testing is just kind of an indirect measurement of exposure to electric fields. And you go typically and you start turning circuits off. Boom, 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 no change, no change. Eventually, you turn one off, boom, the body voltage just plummets. It's usually the plug loads around the bed. And so that illustration of going to the circuit box, physically turning off the circuit, watching the body voltage go down, or measuring electric field some other way and watching that go down, you can automate. Some people don't like walking into the garage or the basement to turn off that circuit. So you can automate that with a remote control. An electrician installs this, and it essentially turns the circuit off back at the electrical panel.
Right. So and I know about these because I've got one. In fact, I've got 2 of these installed.
Is it remote or automated?
Mine are automated because I'm in Europe, and so that's the great thing about them is you just get the electrician in. He scratches his head and goes, "Oh, what's that?"
Right.
And then, so I've got an electrician with a brain. No offense to electricians, but you need an electrician that's that's
outside the box. Yeah.
Yeah. And so he just installs this thing on the bedroom circuit, and on another circuit, and then there's no electricity. When I sleep, then I said there's no electricity. We're very low. We're like below 70 millivolts, if memory serves, 60 millivolts, something like that, which is okay. And it's not perfect.
Great.
So for people listening, it's great. And what that means is that it's like if I get up in the middle of the night and I'm going for a pee, then I hit the light switch and the light comes back on. And that's the great thing about it. Just completely forget about it. And mine is a gigahertz solutions, which I use, which are from gigahertz, like the meters that you were talking about. Yeah. It's a really great solution.
It's a fantastic solution for those who live simply or in Europe. What we find in the States, are you familiar with some of the problems that we have?
Yes, I am. But you can just talk us through very briefly.
Okay. Well, we have so many what they call phantom loads, things that are constantly sucking just a little bit of amperage. that, whether it's a plug-in printer or even a surge protector with a little light on at night, those small loads are enough to fool the automated control demand switches to think that you need to have it on. And so what we were finding is a lot of people thought it was working and they thought it would be turned off. And when we actually go in and test, it's like, no, it's always been on because you have too many GFIs or you have too many just little phantom loads that they were unaware of on that circuit. So in the States, the main distributor, Rob Metzinger of Safe Living Technologies, I think he doesn't sell them anymore in the States. He just does the remote because they were getting too many complaints. So now we're just installing the remotes.
Right. And with my situation is we have, that's the other thing, which I personally recommend is, there is nothing in our bedroom apart from on my wife's side. She's got an electric lamp. I don't even have an electric lamp. And I use like a flashlight, to read at night because I don't want the electricity at night and I don't want the lights,
right?
The bright lights, which is another whole subject altogether.
Yeah.
But so yeah, it does require a certain philosophy and discipline about this whole question. But I'd like to talk about the third scenario, which is what I guess will apply to most people. Yeah, sure.
Well, sorry to interrupt. So just a few more on the design side.
Yeah, sure.
So the electric fields are relatively easy, either through a demand switch or using metal clad wiring or flexible metal clad conduit. But we also do some magnetic field shielding periodically. So if there's a point source that we know about, like a refrigerator or a utility sub panel or the main electric panel, or transformers that can't be remotely located away from a high use area. In those particular cases, we also recommend installing magnetic field shielding. That would be the end of our, that's typically, and then some for dirty electricity, which like you said, we haven't talked about, but we can do some line conditioning as part of the design phase as well.
Okay. So yeah, that's great. And so, so if we could talk about this third scenario then, which is where we've got EMF issues in an existing home, which is what, where most people are going to be that are listening to this, I would imagine, in terms of what to look for. And so we've got the four categories, haven't we? We've got the radio frequency, radiation, electric fields, magnetic fields, and the dirty electricity, these high frequency transients, which are on the electrical wiring. So yeah, so if you could perhaps speak to that existing home, and we're looking, just kind of perhaps the common things we need to look at, and maybe the less common.
So an existing home, I kind of back it up to what we would do in a design review process, and also look at those things from the planning and layout standpoint. Are you in the neighborhood? Is there an external source that we want to shield from? As a renter, for example, you could install a bed canopy to shield from an external cellular antenna or a neighbor's Wi-Fi in a neighboring unit, for example. But then we kind of get a little bit more granular, move inside the building, do a walk around the exterior of the perimeter and inside, look at where the utility sub panels are, look for clues of any knob and tube wiring that might be in the existing home. Turn everything on and walk around with a Gauss meter, see if there's any evidence of wiring errors. And oftentimes as building biologists, they focus on the sleeping areas. So spend a lot of time in the bedroom, walking around, doing magnetic fields, electric fields, and RF. And more often than not, people who call us, oh, there's a cell tower, I just noticed, or a cell tower just went in down the street, I'm really worried about it. We say, okay, we'll come check it out. We test in the front yard, and then we go inside, and all of a sudden it's higher inside because of the wireless baby monitor, or the cordless phones, or the cellular phone repeater station, and the Wi-Fi. Start unplugging all of those things, and it drops down to far less than it is outside, and we illustrate that more often than not, just with a little education, people can have more control than they think, based on what's plugged in their buildings. And in the States, there is a lot of wireless technology. It's really rolled out, and as part, I'm still involved with the green building movement, and a large part of their push is smart technology
Yeah.
that can interface with the utility company and only draw power when there's power available. And smart technology that's monitoring indoor air quality parameters as well, and constantly sending minute-to-minute updates via a cellular antenna in some cases for carbon dioxide, carbon monoxide, VOCs, particulates, all of these things that we really want to know about, but unfortunately are being transmitted using radio frequency radiation. And so what we find most often is people call for an external complaint, be it a large telephone or a power line or a new cellular antenna. You go inside the house and you say, oh, you've got a wiring problem that is far worse than that external power line.
Yes.
Or we just unplug these 5 devices, then we've really eliminated your radio frequency problem. So a lot of it's education, like what you're doing with this presentation.
Yes. And it is a crazy world in that everything is just wireless, it seems. Everything you can buy now. The most improbable things are wireless. Things you never imagined could be wireless, wireless toothbrush, wireless this, wireless that.
Yeah.
Why? But why? Because people want wireless, because wireless is, I guess it's perceived to be better. Clearly it's not. It is better in the sense that it's, the functionality often, although that's questionable sometimes, something, you just don't need wireless functionality on. But yeah, there's people love wireless. People don't understand that there is a downside, and so there are downsides. So as you're saying, there's all these devices which are wireless now, can be your burglar, very often the burglar alarm, is it not? And the furnace, the heating unit, many things. Everything
security sensors now, for sure.
The most horrible has to be, and just a quick word on that, is the baby monitors. Oh wow.
They can really create a lot.
Such bad news, because if there's one person, little guy or little lady, you do not want to be exposing to radio frequency radiation, then it's babies, really.
And some of those are so strong. It's remarkable how you can really measure a lot of radio frequency radiation off those wireless baby monitors. Peter Sullivan, I don't know if you'll be interviewing him, but he had an interesting hypothesis, because he spends a lot of time in the autistic world, autism conferences.
Yes.
And how many autistic children are nonverbal. And have you heard that theory that he had? So some of those baby monitors will only send a signal when there's a sound made. So some of them are constantly, so it's just like a cordless phone. Some of the cordless phone base stations are constantly emitting radio frequency 24 hours a day. Others only emit when you pick it up and you dial out. It's the same with baby monitors. Some are going constantly. Some are sound activated. And he had a fascinating theory that when the child in the bed who happens to be electromagnetically sensitive or already on the spectrum, verbalizes, dad, mom, whatever they say, or grunts, whatever it may be, that all of a sudden that baby monitor turns on for about 5 minutes, and it just trains them not to talk. And it's a fascinating theory, I thought. But it's sad, it's tragic, but if that's true.
It is absolutely tragic, yes. And obviously for me, this is the most tragic, the most scary, the most disgusting, really, part of this whole wireless world that we're moving into is, what we're doing to our children. But there's a few things you said there, which let's go off, and if we can, because you mentioned, so we talked about wireless, but the other side of wireless is wired. And so all our homes, they have wires. And these wires are another source of electromagnetic fields. And could you just talk to that? Because there are situations where, because even in the best of worlds, there will be some form of electromagnetic field being emitted from these wires. That if everything's done correctly, then that will be fairly minimal. But we do have situations where it's off the charts, is it not? So can you just speak to that?
Particularly about wires within a building?
Yeah, so wiring as an issue, because obviously in the US, we've got the National Electricity Code, yeah, so everything should be wired according to that. And but that is not a guarantee that we're not going to have EMF issues because of that, is it?
Yeah. No, it's not. So, so yeah, we have a wiring book of recommendation, like a specification for new construction. And you show it to electricians, and like you said, they scratch their head. They say, "Oh, of course, we all do this." But many in the electric code that people say they do that they don't. So there's some very common wiring errors. And so we could separate wiring from the low voltage data wiring, which building biologists generally don't find as a major concern unless there's some wiring error on the AC power side that tends to shed stray current onto the low voltage. In general, low voltage wiring for data, like an Ethernet cable, or a hardwired security system, or a telephone wire, is not problematic. Mm-hmm. But the alternating current AC power side, we find wiring errors all the time. And so those wiring errors can result in elevated magnetic fields far higher than what you find underneath a transmission power line. Mm-hmm. And we always get the calls from people who are moving in or about to buy or rent a place that's underneath a power line or near a utility substation. But in reality, statistically, they're much more likely to have elevated magnetic fields from an internal wiring error. Mm. So I might have a few pictures of these common wiring errors. Mm-hmm. And I'll explain perhaps why they happen here. Let's see. Maybe I can share some images again. Let's see what we can do here. So magnetic fields are quite interesting. Let's see. Can you see that?
I can, yes.
So they come off, they kind of emanate like large donuts. Can you see my mouse?
Yes.
Okay. So they emanate like large donuts, and they're stronger nearer the source. And so these are borrowed from a building biology manual. And so it's the rule of your left thumb in terms of how magnetic fields emanate from a particular conductor. Mm-hmm. So if you hold your left hand up and you look at it, the way that your fingers are pointing is the direction of the magnetic field is traveling.
Okay.
And so that occurs, and when you have a balanced load like this, remarkably, it's like holding your two hands together in opposite directions, and they balance each other out. So a balanced load, typically you'd have a hot and neutral wire right next to each other, cancel each other out in this fashion. And just a simple visual would be, you got your left hand, you got your right hand, and somewhere in the middle, these are balancing each other out. Mm-hmm. When it's not balanced is when you get in trouble. And so when it's not balanced, you get stray current traveling on one conductor or another where it shouldn't be. Mm. Let's see, I'm going to skip some of these. And I think, these are some common wiring errors. And we find these all the time. So where two branch circuits are feeding one electrical junction box, like behind these two switches.
Yes.
Or up in an attic, you find this. And they've mixed the neutrals together.
Yes.
The diagram. These, if they're from different branch circuits, this is a code violation. And you find this all the time.
Yeah.
And the easiest, and electricians will swear up and down, oh, we would never do that. And every time, if we include in the specification to return when the electrician thinks they're done, we return, we do some verification testing back at the electrical panel. And we say, oh no, sure enough, neutrals from these two circuits are touching somewhere out there. And they have to go dig around and find things like this. But this can take a lot of time and be challenging and expensive to fix later. And it's a code violation that does not negatively impact how the lights work, how the dishwasher runs. Everything still works as it should. The electrical inspectors for the city or the county or whoever is doing inspections are not trained to look for this. And most electricians just think, oh, if it works, what's the problem?
Right.
But the problem is that it creates stray current, and you no longer have that balanced load, and that can create elevated magnetic fields throughout a building, similar or worse than being right underneath the high voltage transmission line.
Yes. And just to put this in context for people that are watching, is that according to certain experts, these and the reason these experts are saying this, by the way, is because this is what the science is saying, is that magnetic fields are the greatest cause of concern, more than radio frequency radiation. And obviously that's open to debate, and it's a generalization, but certainly what we are saying here is that these, magnetic fields from wires, these electromagnetic fields which are being emitted from wiring, can be a very big deal.
Mm-hmm. Absolutely. And building biologists try to take a very holistic approach to that. Typically, most building biologists don't have medical degrees, so we stay out of the medical discussion. But we do indicate that, getting back to as close as you can to nature practically is the goal. That's the gold standard. And so we look at both, we look at DC stuff as well that we're not talking about today, but we look at alternating current, low frequency electric fields, magnetic fields, dirty electricity, and radio frequency radiation, and try to consider the whole picture. There are a lot of people who believe that only one of those aspects is the factor.
Yeah.
And that may be true for some populations. I know certain individuals, dirty electricity just drives them nuts. Others who have wiring errors, for example, and they plug in a lot of dirty electricity line conditioners or filters, that can, in some situations, that can aggravate a magnetic field problem if there's a wiring issue. And then we have other clients who that makes it worse. So you plug in filters that help half the population, it hurts the other half. And so it's a very complicated, from a medical standpoint, we kind of shy away from that. Say, do what works for you. I think that you'll have other guests much more knowledgeable on the medical side, but there's a lot more peer-reviewed published studies about the AC magnetic fields than there are about electric fields or dirty electricity. And there's a growing amount of evidence and discussions on the on radio frequency radiation.
Yes. And I'm going to be interviewing Dr. Paul Heroux, who's in Canada, and he's really one of the leading lights on this. I've had him on my podcast before, but he's done a lot of research on this very question. So that's information that people might be interested in. But so yes, you were talking about these wiring errors and about these code violations, as you call them. And as I understand it, the thing to understand about these code violations is that you're going in, the EMF guy, you're seeing that they're there, but the people, the electricians and the regulatory authority, they're not necessarily seeing they're there. Is that
absolutely not?
Yeah. So there's those code violations which are going in many cases, unless they've got an expert like yourself on their team, people that have a property, or that they're highly informed on this, and maybe they've been watching the EMF Health Summit. So we've got these code violations. And then what about respecting the code, but we still got a problem? Does that happen?
Yeah. I mean, all the time. So like we tell, typically it's a higher end client who can afford to have us come in up front, do a design review, do an electrician kickoff meeting where we provide them with our specification. We walk through the house that's already been framed out. We explain what we'd like to see. We show them images such as this, where we're trying to, these are images from Carl Riley's book.
Yes.
A great resource, a great, both in person and his book. And we show them all of these things. Look, this is how it should be wired. This is how the panel should be laid out, and explain why, and how this would reduce point source radiation for magnetic fields. They're all nodding. Sure, we always do that. And we give them a list of common wiring errors to avoid. Oh, we never do that. I say, okay, well, at the end of the job, when you think you're done, we come back and we do diagnostics in the panel, and I explain to them what diagnostics we're going to do. We're going to look over the electrician's shoulder while the electrician pulls a neutral off the neutral bus. Each one. Have you ever done that with somebody?
No.
Have you ever? So there's a protocol for this, not to be tried at home. Learned in advanced building biology seminars, and it makes sense to electricians when you start talking about stray current and amperage. If you talk about magnetic fields, they roll their eyes. They think you're crazy.
Yes.
But if you're talking about stray current, they start to get it. And so we say, here's what we're going to do. We're going to pull a neutral off of the neutral bus back in the main electric panel or sub panel. And we're going to test the continuity from that one neutral to the neutral bus. Should there be continuity, meaning that somewhere out there it's touching another neutral? And they say, no, that's its own neutral. It shouldn't have any touch anything else. And we say, right. So we're going to come back when you think you're done. We come back, and I think they're done. We go through 1, 2, no problems. Beep, third one, oh, tag it. Put a red flag on it. Put it back. Keep going down. 2, 3, 4, 5, sometimes 8 different circuits with neutral to neutral or neutral to ground faults out there. They say, this is what we talked about. This is what shouldn't be there. Now you have to go find them. And they have to go open up all of those other panels. They have to open up all of the other junction boxes until they're able to find where those neutrals or neutral to ground faults occurred. And I've never had, we've probably done 50 of those. Yeah. And none of them have ever passed on the first round.
Yeah.
Like the highest end electricians in the San Francisco Bay Area nodding, saying, yeah, sure. Oh, our guys would never do that. And I say, yeah, that's what the last 40 guys told me, but we always find it. And they say, oh, it's not going to happen on our job. Yeah. Show up, boom, 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 boom. Yeah. Inevitably, there's at least 1, sometimes 10. Yeah. And it takes them time. And if the spec is written well, it should be on their time, not on the dime of the owner, to go repair their wiring errors. And sometimes that can be rather contentious because they want to be done with the job. They thought they were done. Then this EMF guy comes around and starts talking about stray current, and they're not happy because they have to spend more time when they're not getting paid. But it's unfortunate that that's what it takes to get a job done right. Yeah. You have to pay an independent third-party watchdog like us to come in and do. They're not very sophisticated diagnostics, but nobody else knows how to do them. Again, that shouldn't be tried by a homeowner or anybody who's not a licensed electrician. But that technique will inevitably find wiring errors in just about every building. And whether or not it's a big load and whether or not the path of that stray current goes under or near a high use area is important, because sometimes it doesn't go, if it's not impacting a sleeping area, if it's not creating a huge magnetic field, okay, maybe you can live with it.
So that is quite technical, what you're explaining there. I imagine for most people to perhaps everybody doesn't follow what you're saying, but and you do need to be an expert to do this with an electric. Obviously, you don't want to be playing around with electricity at all. Anybody that's not a licensed electrician. But it's that aside, we don't need to be an EMF expert or a licensed electrician necessarily to identify that there is a problem if we have an EMF meter. Agreed? If we have an EMF meter like now I know the professional meters which you've got on the desk there, but I know what I call the consumer meters, which is entry level EMF meters which are not nearly as sensitive as what you've got, but which are really come on leaps and bounds in the last few years in terms of sensitivity and functionality. And for instance, the Cornet ED88T Plus, got to mention the new Tri-Field TF2, depends what you're wanting exactly.
I haven't seen the new Tri-Fields. Are those good? It's a newer model?
It's a brand new model. So the classic, which has been around forever, is the 100XE, which knows, which even Carl Riley talks about in his book, which is an absolute reference, one you were talking about before, which is called Wiring Issues or Wiring, something wiring. So it's a Carl Riley book, and who's an electrician, qualified, esteemed electrician. And so he talks about the Tri-Field 100XE, but the new version is called the Tri-Field TF2. Obviously, are built by Alpha Labs, and they have a whole range of meters, but they've got one or two which are sort of the mainstream meters. And the new one is the TF2, which is a great little meter. Which is we've got it measures radio frequency, radiation, electric fields, magnetic fields, like I was talking about, which is what. So what I'm saying here for people is, it's not that you don't need an expert like Alex Stadtner, and it's not to replace an expert like Alex Stadtner or somebody else who is an EMF expert or a building biologist or similar, because it's not just building biologists that can do this work. There are other people, but it's a great institute. But yeah, you can do this. You can certainly do a lot by yourself with an EMF meter.
Absolutely, and it can be a first indicator, an inexpensive first indicator to see if there is a bigger problem. So that's strongly recommended for people to experiment with their own meters first. Yes,
and the advantage is you've always, once you've bought it, you've always got it on hand. So these are not mutually exclusive. The EMF guy, the meter. Both. Why not? Really, it's better. Both is better. But certainly having the meter means that, because you need to be monitoring this situation pretty much every day, because that
things change.
About paranoia. And certainly if you're electrically hypersensitive, which certain people that are watching this are, then you know what that means. Doing that, the more you focus on something, the more it grows. And so you do not want to be on your EMF meter every day. But that's my personal viewpoint.
Yeah, but after you remodel the kitchen, would be a good time to pull out the field meter and see if anything's changed.
And even when you change a light bulb, when you do anything electrical, when you buy a new device, anything.
Right.
I once had the occasion where we bought a new refrigerator, like you have in the States. We call them the American refrigerators, and got in the kitchen, and I was, what's going on? And got the meter out, and there it was. In fact, it was still in the wrapping, so they had to take it back, and we got it on. And so you really do. Yeah, everybody, in my view, should have an EMF meter. But I'd like to talk about
appliances in particular can be problematic. They can have internal wiring problems.
Yes. Exactly. And so the thing works fine. You switch it on, it gives you cold, gives you ice, this, that, and the other. But there's a wiring problem. That's one scenario. Second scenario is you switch it on, the wiring's fine, but it's a smart refrigerator, or it's a smart TV, or it's a smart, electrical vacuum cleaner. Everything's smart, but smart is not smart, because that just means it's radiating you, zapping you with radiation all day long. But yeah, just want to go back to something you touched on very briefly. And I know you're not an expert on this. This is a big subject again, but grounding. So grounding an electrical system. So what we're still on the subject of electrical wiring here. So grounding, all electrical systems should be grounded. Agreed. So in the US, we have, and these are some notes. I spoke to Spark Burmaster a while ago. We got the black, which is the hot, typically, the white, which is the neutral or grounded, and the green, which he calls a grounding conductor. Those are terms. That's typically what you're getting in the US. Obviously, it depends where you live, what part of the world you live. Those colors will be changing, but that's often what kind of electrical system setup will have in different civilized countries. So this grounding conductor, every building, every home should be grounded. Why should it be grounded? And, how does that work? And how big a problem is that?
Well, it's primarily, it is a big discussion item. It's not my area of expertise, but it's primarily there as a safety. So this is just an image. I don't know if you can see this now, but of the hot, black, neutral, which is white, and the ground, which is typically green or just a bare copper wire. So it's there in general for electrical safety. And so a circuit should trip and turn off if there's a fault between the hot and the ground, or the neutral and the ground. And so those things are there for an electrical safety. So if you stick your finger accidentally in a plug, or a kid puts a nickel into an outlet, the primary reason for everything to be grounded is for electrical safety. That's my understanding. If you have any type of shielding, then your shielding to work against electric fields has to also be grounded. So if you're using metal-clad conduit or solid metal conduit, that will also always be grounded. Mm-hmm. And then all of the main incoming utilities are grounded, again, largely because of for electrical kind of fire and electrocution safety. But there are some problems that can occur if grounding for those separate utilities. So say you've got data, phone, cable, internet. You've got maybe a gas line coming in. You've got a water line coming in, and you might have a metal water pipe going out for a sewer. And then you've got power. Those are the primary utilities: water, sewer, power, data, gas. So if there are wiring errors in a neighborhood, for example, any of those utilities can become a conduit to carry stray current. And so some of the rules of best practice, rules of thumb for grounding would be to have all of those utilities come in on the same corner of a building and have them all grounded within 10 feet of each other. It's not to have power come in on one side of a building, water to come in on another, and to somehow run a grounding wire connecting those underneath the entire house. So another typical design rule would be to install those all near one another and use real grounding rods, not an OOFR ground for the entire slab. And those things also can be measured. So say all the loads are on or in a house. Sometimes it would change, like I said, if there's a neighborhood wiring error, it might change based on the neighbor's patterns. But you can typically walk around those utilities themselves, and where they're physically grounded, you're supposed to be able to see that as a code requirement, where they are physically grounded. So on a water pipe, for instance, there's usually a large bare copper wire that goes to a nearby grounding rod, or otherwise connects to the main electric panel. Anyway, in those areas, you can use a magnetic field meter and see if there's stray current just by getting close to any of those utilities. And if you see magnetic fields go up significantly, then you know there's stray current on that utility. And then when you're talking to electricians or people in the utility field who roll their eyes about magnetic fields, then you can show them by using a clamp-on amp meter and say, look, there's amperage on this gas line. Does that sound right to you? And the utility companies do not like it when the gas lines are carrying stray current. They're very reactionary to that. Right. If it's on phone, if it's on the plumbing, they're less interested.
Right.
Talk about magnetic fields, again, nothing gets done. But if you can show, look, you've got 3 or 4 or 6 amps on a water pipe, and then you say, what's going to happen next time an electrician comes or a plumber comes and cuts this water pipe? Somebody could get electrocuted. Yeah. That will motivate utilities to get the stray current off.
Yes.
And that's often not a problem, but it's an easy thing to measure. And so grounding can be important. Where things are grounded is critically important. If they are, and if there's carrying stray current, then all bets are off, because the grounding system connects every electrical component and utility within a building. And so that creates just this spider web of potential pathways for stray current. which
Yes.
can be complicated to discover and fix.
So good tip there. You don't even need an EMF meter. A clamp on amp meter can do the job, a different job, but it's giving you information which you can easily communicate with your electrician or with your utility company or whoever,
Right.
to talk about this. And it's very inexpensive. You can get them on Amazon or elsewhere, but like $30 or something like that, and they're really easy to use. But just a question, so are you seeing scenarios where you're going in and there's no ground? Because the ground, just to be clear on people, the ground is absolutely fundamental. It's like just the number one thing we have to have in an electrical system. It has to be grounded. It's like, otherwise big fire risk. And so all properties should be grounded, all electrical systems. But are you finding, have you ever seen, or is this regular, or does it happen, properties which are not grounded?
No. Typically here, everything is grounded one way or another. It might be hidden in a wall, but typically there has been some ground.
Yeah, I'm asking you that because I know this does exist. For instance, one of my clients who's in Holland, she is, there's no grounding on her property, and she's in like what we call terrace, which is like a shared wall. And everybody's like that. There's no ground. So this is in certain countries it's quite common, but it just depends where you live. But it is fundamental.
In the States, it's not. If there's ever been any permitted wiring upgrade to a building, it will be grounded.
Yes.
I think they're pretty good about, the electrical inspectors in the cities and counties are pretty good about monitoring that, but not necessarily the more.
And I mean, I know my wife has a shop, which she took over last year. So obviously we're pretty keen on all this kind of thing, and I'm looking at what's going on in terms of EMFs and all that. And the electrician came in and said, "Oh, there's no grounding here," and this is in this is in like a big unit, big block, with many other things and no ground. They were just hanging there, not connected to anything. So it does happen. It does happen.
Wow. No, we haven't seen that very much here in the Northern California.
Yeah. And then I just want to touch on something else, which I know your company also does testing with, and that is alpha and gamma radiation. And I just want to touch on that briefly because it's so rare I talk about this. And so this is really, we're talking very high frequency, which is supposedly quite rare, but I know you do have meters to measure this. So can you just talk about that as an issue? Obviously, this is a real, because, the controversy about EMFs is that they're safe because they're non-ionizing, whereas this is ionizing. And so nobody's arguing that it's not dangerous. It is dangerous. So you have equipment that can measure this?
Yeah, with a Geiger counter, you can do some ionizing radiation testing. And this is just an example of one case study. So sometimes somebody's doing a new kitchen or new floors, and they want to have us measure the granite countertops or the granite flooring. And so we'll come in and we'll get a baseline outdoors in a couple areas and compare that to what we find in a slab. And so this is one just quick data point here, comparing just kind of a raw counts, excuse me. And the outside baseline, you can kind of see is around 280. Everything else is kind of below 300. All of a sudden, this one particular slab, and I could tell just walking up to it, was 205% over the outside baseline. You could tell just walking up to that slab whether or not it was, you could just tell. It was, with the Geiger counter. Click, 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 click. Wow. It doesn't happen very often, but there are hot slabs out there. Yeah. We have a woman in the field today testing a cat. The cat was treated radiologically for cancer, and that she's having family members who are sensitive over. And they told her that the cat should flush the radiation by the end of the week. She wants to test before her house guest gets out here. So one of our inspectors is out there today with a Geiger counter inspecting this poor cat. So yeah, we do that quite a bit. Radon is probably a more likely source of ionizing radiation in most buildings. And that's very common. I mean, it kills over 20,000 North Americans every year from lung cancer. So that's a very significant life safety known threat that we have.
So radon, it's a gas, little talked about again, which is in many homes, affects air quality and comes principally from the soil.
Subsurficial uranium that's decaying. It's slowly decaying, and it sends at one point, there's a radon atom, and as that atom kicks off electrons, that can be problematic if it's within our lungs. And so people can ingest it in water, or when you're bathing, if it's coming from a well, for example, or more often there's cracks in a slab, or the house is negatively pressurized, and so it's just sucking soil gases up, and then within that can be radon. It's very easy to test. There's some do-it-yourself test kits that are quite reliable. It's one of the few regulated substances in the States that you have to have a special certification to test for. And anyway, it's easy to test. You get a lot of variation. Unfortunately, if you test one day, it might be low due to pressure differentials in the building, or just what's happening subsurficially with the soil gas pressure. And then you test the other day, it might be high. And so when you're doing like a pre-purchase test, and it's a very short window, 48 or 72 hours, you could miss what's happening. So if you're in an area, and it's been pretty well mapped out, there are areas with known problems for radon. And in those areas, oftentimes the code requires, if you're building from scratch, to do some, they call it sub-slab suction systems that negatively pressurize beneath the slab and blow that air out above the roof line of a building. Yes.
Okay.
So, but the hot granite is kind of unusual. And there, there's a famous story in the building biology world of a building biologist going in and testing, goes in, tests the granite, and says, "Gosh, wow, it's hot." And I've probably seen that 2 out of 100 times. It just doesn't happen very often that you find a hot slab.
Yeah.
The building biologist goes in and he tests it, and he says, "Gosh, I tested this 3 times. I wasn't going to say anything. It's rare, but I believe that this countertop has some radioactive decay occurring." And the woman lifts up her shirt and shows a scar where she had had a tumor removed right at the level of that counter where she was frequently, chopping vegetables and doing dishes. And the next week they have that counter removed. And nobody would have known unless they had a Geiger counter.
Yes. So very rare.
Cost of Geiger counters have gone through the roof since Fukushima.
Yes. So you say very rare, but very bad news if you do have this alpha and gamma radiation.
That's right.
We're out of time, unfortunately. Could you just remind people where they can find out more about what you do? Sure.
My name's Alex with Healthy Building Science, and we do industrial hygiene or environmental testing. You can reach me at alex@healthybuildingscience.com. And thank you, Lloyd, for getting the word out and having me as a guest.
Well, thank you, sir, for being part of this EMF Health Summit. It's been fascinating talking with you, interacting with you. Got some really great knowledge on this, some very interesting stories, enlightening. So great information. Thank you.
Thank you.
And for all who have joined today, thank you for being part of this movement. Stay tuned for the next session. My name is Lloyd Borrell. Take care. Thank you. Bye-bye.